Professor Belfrost's science class is back.
Okay, so welcome back to my lesson. And today, as usual, I'll give you another lesson. And today, we meet again on chemistry class. But today episode will be not too long. This is the last lesson. Yeah, not last lesson actually. Yeah, the last explanation lesson on this chapter. The next lesson on this chapter will be just a review exercise. Okay. So let's review a little from our last lesson. So percent composition is defined as the percentage by mass of each element in the compound. Empirical formulas are derived from experimentally measured element masses. By three steps, this is derive the number of moles of each element from its mass, divide each element smaller amount by the smallest mole amount to yield the subscript for a tentative empirical formula, and multiply all coefficients by an integer if necessary to ensure that the smallest whole number ratio of subscript is obtained. Yeah, that's the three steps. The next point, an empirical formula mass is the sum of the average atomic masses of all the atoms represented in empirical formula. A relative amount of a given solution component is known as its concentrations. A solid is a component of a solution that is typically present at a much lower concentration than a solvent. A solid concentration are often described with qualitative terms such as dilute or concentrated. A molarity is defined as the number of moles of solid is in exactly one layer of solution. A solution itself is um, must contain one component with a concentration often contain one component with a concentration that is significantly greater than that of all other components. And this is called the solvent and may be viewed as the medium in which the other components are dispersed or dissolved. While solid is a component of a solution that's typically present at much lower concentration than the solvent, and solid concentration are often described with qualitative terms such as dilute and concentrated, which I have. This is another point. Okay. Okay, that's done for the review. Let's start our today's lesson. So today I'll talk about dilution of solution. This is a very important process. So dilution in chemistry is the process whereby the concentration of a solution is lessened by the addition of solvent. For example, you have a glass of iced tea which becomes increasingly diluted as the ice melts. So the water from the melting ice increases the volume of the solvent and the overall volume of the solution, thereby reducing the relative concentration of the solids that give the beverage its taste, which can be shown as you see the figure that I've provided. This one. So both solutions contain the same mass of copper nitrate in the figure. Okay, so the solution on the right, okay, is more dilute because the copper nitrate is dissolved in more solvent. So dilution is also a common means of preparing solution of a desired concentration. Okay, we always make use of these in many laboratory. For example, we have in chemistry laboratory, in a biology laboratory, and we're preparing for preparate and something like this. Okay, so by adding solvent to a measured portion of a more concentrated stock solution, a solution of lesser concentration may be prepared. So for example, that commercial pesticides are typically sold as a solution in which their active ingredients are far more concentrated than is proper for application, so it must be diluted. And a simple mathematical relationship can be used to relate the volumes and the concentration of solution before and after the dilution process. So here's the solution molarity and swollen liters, and also its relationship to the number of moles of solid in the solution, which is N equals M times L. And this expression can be written as shown. So N1 is M1L1, N2 is M2L2. 1 and 2 refers to the solution before and after the dilution. So since the dilution process doesn't change the amount of solid in the solution, then N1 must equals M2. So M1L1 equals M2L2. This is the final formula. But actually, this is not the first steel formula that we'll encounter in books. So the notation used is mostly C1V1 equals C2V2, where C and V are concentration and volume respectively. So here's the example for you. Say you have 0.850 liters of 5 molar solution of copper nitrate, which is diluted to a volume of 1.8 liter by the addition of water. So what is the molarity of the diluted solution? So here's the solution. So the stock concentration C1 volume V1 are provided as well as the volume of diluted solution V2. So we need to rearrange to get the formula C2 equals C1 V1 by V2. So since the stock solution is being diluted by more than 2/4, okay, then the diluted solution concentration is expected to be less than 1/2 of 5 molar. And substituting the given value that it yields, this is 2.36 molar, which is as expected. Okay. The second example. So what for of 0.12 molar of bromic acid can be prepared for 11 milliliters of 0.45 molar of the same acid. So by using the same procedure, also apply the same formula, we obtain this 0.041 liter, okay, which is 41 milliliters. Third example, a volume of 1.59 molars of yeah, what is this? Potassium hydroxide, okay? Not potassium, I think. Calcium hydroxide, okay? Is required to prepare 5.0 liter of 0.10 molars of the substance. So yeah, by rearranging the formulas before, we can obtain that the volume before deleted is 0.314 liters. You should read it by yourself, okay? I'll not explain it because this is self-explanatory. And now let's learn another units that related to solution concentration. First is what I want to introduce is mass percentage. So in earlier that I've introduced you with percent composition. So percentages are also commonly used to express the composition of mixture including solution. The mass percentage of a solution component is divided as the ratio of the component's mass to the solution mass, and it is expressed as a percentage, which is mass percentage, which is mass of a component divided by mass of solution times 100%. Actually, there's no accent or apostrophe there. Okay. So mass percentage is also referred by similar names as percent mass, percent weight, percent, and other variation to this thing. Okay, so there are many symbols too: percent mass, percent weight, and WW percent. Okay, so mass percentage are popular concentration units for customer products. For example, you may encounter this in the typical liquid bleach bottle, which is written sodium hypochlorite as being 7.4%. Then you can also have expect, okay, a 100 grams sample of bleach would therefore contain 7.4 gram of the sodium hypochlorite. Here's example practical for you. So say that you have 5 grams sample of spiral fluid contains 3.75 milligrams of glucose. That was the percent by mass of glucose in the spinal fluid. Then by utilizing the formula before and by converting the milligrams to gram, so we get the percent of glucose, the mass percentage of glucose here is 0.075%. So note that while any mass unit may be used to compute mass percentage, that the same unit must be used for both the solid and the solution, so that both cancel, yielding a dimensionless ratio. Okay, and any identical mass unit will work. The second example, so we have concentrated hydrochloric acid, uh, which is of 37.2% of chloric acid that's commonly used as a laboratory reagent, and the density of the solution is 1.19 gram per milliliters. What mass of the chloric acid is contained in 0.5 liters of the solution? So here the acid concentration is near to 40%. So 100 gram portion of the solution would contain 40 gram of chloric acid. And since the solution density is greatly different from the that of water, the reasonable estimate of chloric acid mass is 500 gram. Our solution is about 5 times greater than 100 gram of the machine. So actually we need to follow the procedure which is as shown. So we have 100 milliliter solution times 1.19 gram solution per milliliter solution times 37.2 gram of chloric acid, which is the molar mass, okay, over 100 gram of solution, and yields 221 gram of chloric acid. And this is very near to our rough estimate, which is approximately 200. Next, another unit, which is volume percentage. So liquid volumes over a wide range of magnitudes are conveniently measured using common and relatively inexpensive laboratory equipment. So sometimes we need to use this thing, okay? So it is volume percentage, percent for or PV percent, okay? This is volume solid over volume solution times 100%. Here's the example. So we have isopropanol, which is usually sold as a 70% for aqueous solution, and the density of isopropyl alcohol is 0.785 gram per milliliters. And how many grams of isopropyl alcohol present in a 355 milliliters of bottle of rubbing alcohol? So by using the definition of the volume percentage as stated in the formula before, that we can written as shown. So we have 355 times 7 over 100 milliliters times 0.785 grams over 1 milliliters of isopropyl alcohol. So it gives us with 195 grams of isopropyl alcohol. Now, new unit, mass volume percentage. So mixed percentage units derived from the mass of solid and volume of solution are popular for certain biochemical and medical applications. So this is just a ratio of a solid mass to the solution volume expressed as percentage. So for example, the physiological saline solution used to prepare the intravenous fluids has concentration of say 0.9% mass per volume. That indicates that the composition is 0.9 gram of solute per 100 milliliters of solution. Okay, that's it. So very low not solute, solute concentration are often expressed using appropriately small units such as ppm or ppb, okay, parts per million and parts per billion, okay. So like percentage units, then these two may be defined in terms of masses, volumes, mixed mass volume units. There are also ppm and ppb units defined with respect to number of atoms and molecules too. So here's the definition of ppm and ppb that we'll use, which is the mass space. Okay, so here's the example for the ppm and ppb application. So according to the EPA, the concentration of lead in tap water, which is 50 ppb, that the remedial actions must be taken. So what is this concentration in ppm, and at this concentration what mass of lead in micrograms will be contained in typical glass of water, which is 300 milliliters. So here's the solution. So by definition of the ppm, ppb unit may be used to convert the given concentration from ppb to ppm. So 1 ppm is actually 10 to the power of 3 ppb. Okay, so it gives us 0.015 ppm. Yeah, since the volume of solution is given, its density must be used to derive the corresponding mass. And we assume that pure water is used here, which is about 1 gram per milliliter in density. And by rearranging all the equations needed, that we can get the result. Okay, so the mass solid is ppb times mass solution over 10 to 9 ppb. So mass solid is 4.5 times 10 minus 6 gram, which is actually 4.5 micrograms. Okay, that's all. Just short lesson today. Here's the exercise that you need to work for yourself and check your answer to the solution I've provided in slide. Take a screenshot. Okay, 7 questions. I think that's enough. If you want more, maybe you can contact me. Okay. So here's a little quote for you for today. So Kamala Iring Kimball, I'm sorry if I misspell it, once said, "You do not find the happy life, you make it." Okay. Also, your success, you make it. Okay. There is not something as destiny that gives you success. Success is defined by how you do, how you prepare. Okay. Yeah, that's all. Thanks for watching. Subscribe, give a like, comment, and share this video to your friends. I'll be back on every Tuesday and Thursday. And don't forget to visit my website, Science with XYSD, our website, sciencewithxysd.unaux.com, for accessing more free learning resources. Keep watching and be thoughtful. Goodbye and see you.